In this video, I will repeat one exercise we did during the lecture. And in this exercise, we will learn how to use a function to draw or to create a function to draw circles. So it's a lot about circles this year. But yes, let's start with this. So I open now a clean notebook. Make sure that Julia is the active kernel. You probably want to save your notebook to give it a name. So we will do some plots, therefore we want using plots. Let's do that. We get a green tick mark upon pressing play. What we did initially in the lecture when we were drawing circles, we were first providing the value of a radius. So let's make r equal 1. And let's store the coordinate of the centroid of the array. So this is a vector that contains the x position of the coordinate. Let's put it to the center, and the y position of the coordinate. Then we need to define the angle that will vary between 0 and 2 pi. Let's put 100 points. After this, once we have the value of the angle, we can use the parametric equation of the circle to compute the x and y coordinate of each point around the circle. So we have r times cosine theta. Now we should be careful. Theta is a range. So if we want to use the cosine, we need to broadcast cosine because we want to take cosine of each of the individual entry of theta. And we can also add the offset to each of the entry. So here we want to access x0 of coordinate 1. This will be this guy here. And we do the same for y. Boom. Except that it is a sinus here. And we want to access the y, the second component of the x0 vector. This is 2. Once we have this, we can plot x, y, and we can directly set the aspect ratio to 1. And then we get a beautiful circle. So here we have the important information, and here we have the core of the action. So this is something we give somehow as input information, and below is the main action. So this code can be changed to a function. Then we will be able to use it many times in different ways. So let's copy paste the code. We put it into a code cell and we type the keyword function. We give this a name, plot circle, and we need to define input arguments. So what are the input information here? Input information are variable r and vector x0. Once they are defined as input argument, they should be removed from here because you don't want to override the values. Then we want this function to plot not only once, but we want it to plot many times over an existing figure. So we will put an exclamation mark here. This means we are going to modify the open plot object as each time this function is being called. As all functions, this function should be closed with the end keyword. can indent this. Voila, let's press play. We get a green tick mark, so the function is ready to be used. So first we want to check whether we get the same result as without using the function. So let's check we get the same result as in the first cell. So we first create an empty plot. So let's make it plot and aspect ratio equal 1. We have an empty page, and on top of this we want to call our function, and we give 1 as a radius, first argument, and then we give 0, 0 as offset of the center. There we go. So we obtain the same circle as before with a radius of 1. So now we have a function that draws a circle, and the advantage of having a function is that we can reuse it and we can modify the input arguments all the time. So we can make a new code cell and start using this function with completely different arguments. So I'm modifying the radius here, I'm modifying the Y position of the center. Here I will change the X position of the center and put a radius of 3. So you can do this thing, for example, and you get 3 circles. So that's one thing. Then we can go a little bit further. We can even call this thing into a loop. So let's draw an empty figure, aspect ratio equal 1. And now we will store this into a plot object P. So we save this into P. Then let's generate a loop for I 1 to 10. We have a range from 1 to 10. And within this loop, we will call our function plot circle, but we will provide random arguments. So it's going to be a fully unapplied activity today, but still funny. So now we plot 10 circles with random input arguments. The only thing we need to do is to display the figure after the loop. There you go. So we plot a lot of circles with different properties. So that's it. That was an example of generating a function and using it in different ways. Thanks for your attention.